Chapter 1.4, Continuity and One-Sided Limits, Day 3. Removable and non-removable discontinuities. So today we're going to look at removable and non-removable discontinuities. We've kind of talked about that earlier. But I wanted to quickly review what is the definition of a continuity, and then what are types of removable and non-removable discontinuities. How do we know if it's removable or non-removable? So first, the qualifications for a continuity. A function is continuous if it has three things. One, it is defined at that point. Two, the limit exists. And three, the function equals the limit. If the function meets those three criteria at the point, it is continuous. Now for a removable discontinuity, if you remember, a discontinuity is removable if it meets criteria number 2, not necessarily 1 or 3. And a discontinuity is non-removable if it does not meet criteria number 2, right? So a function is continuous if it meets all three values in the checklist, and it is a removable discontinuity if it meets number 2, and it is non-removable if it does not meet number 2. So let's take these three criteria and discuss the continuity of the following functions. So we'll start off with a rational function. As we talked about, a rational function, the criteria for discontinuity is what makes the bottom 0. So we need to start that discussion by factoring this function as best we can. And we can see, when we factor that, x minus 1, x plus 1 over x plus 1, there is a discontinuity at x equals negative 1. Okay, because the function does not exist there. You cannot divide by 0, and negative 1 makes the function discontinuous. Now we need to decide, is it removable or non-removable, and we'll do that by evaluating the limit as x approaches negative 1. Well, as x approaches negative 1 of our function, we can see that x plus 1 cancels, and we get negative 2. So the limit exists, the function is undefined, it's discontinuous, but it's a removable discontinuity. So there's a removable discontinuity at x equals negative 1. Here we have a piecewise function. The candidates for discontinuity are x equals 1, because that's where the cutoff is for all of our discontinuity. So we'll start the 3-point criteria. What is f of 1? Well, f of 1, when x is 1, f is 2. So f of 1 equals 2. Now because it's a piecewise, to evaluate the limit, we need to go from the left and the right. So the limit, as x approaches 1 from the left of our function, we would use the left is right here. If we plug 1 into that, we get 1. Evaluate the right, the limit, as x approaches 1 from the right. There's the right. If we plug 1 into that, 2 times 1 is 2, minus 1 is 1. So the overall limit, as x approaches 1, is 1. So the function is defined, that's checkpoint 1. The limit exists, that's checkpoint 2. However, they do not agree. So this function is discontinuous at x equals 1. And because the limit exists, it is removable. So we have a removable discontinuity at x equals 1. All right, another one. Now you should be familiar with this graph by now. Absolute value of x minus 3 divided by x minus 3, it's going to be a graph. It's 1 everywhere. X minus 3 is positive, and negative 1 everywhere x minus 3 is negative. Now you can see there's a discontinuity because there's a jump at x equals 3. So this is discontinuous at x equals 3. And because it approaches a different value from the left and the right, the limit does not exist, so this is non-removable. We cannot fill in the hole and flow through the function. So we have a non-removable discontinuity at x equals 3. Okay, here we have a piecewise, so evaluate it at the gap. Evaluate it at 1. So the limit, or let's start by, does the function exist? What is f of 1? Well, f of 1 will happen right here, greater than or equal to 1. If I plug 1 in here, I got 1 squared, which is 1. So now let's do the left-hand limit. So approach 1 from the left. Our left is where x is less than 1. Negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. Let's do our right-hand limit. Limit as x approaches 1 from the positive side. So that would be this lower part. If I stick 1 into there, 1 squared is 1. Okay, so these two values agree, so that means the limit as x approaches 1 of f of x is also 1. And these two agree, so this means it is continuous at all points. F of x is continuous. On all real numbers. And again, I'm writing this at interval notation. And finally, another piecewise function. You know what to do. We need to find the value of the function, so we're going to need f of 2. F of 2 is negative 4. We need to evaluate the limit as we approach 2 from the left. Approaching 2 from the left is this one right here, which gives us negative 4. We need to evaluate the limit as we approach 2 from the right. That'll be this one right here. 2 squared is 4. 4 minus 8 is negative 4. Negative 4 plus 1 is negative 3. These two do not agree. So the limit as x approaches 2 of f of x does not exist. So the limit does not exist, so it is not continuous. And it is non-removable, so there is a non-removable discontinuity abbreviating at x equals 2. All right. So, in conclusion, there's a 3-step system for deciding continuity. 1, the function is defined. 2, the limit exists. That means the left and the right hand are the same. And 3, step 1 equals step 2. If those 3 things happen, our function is defined at that point. If number 2 happens, but nothing else happens, or 1 and 3 don't happen, it is a removable discontinuity. And if 2 doesn't happen, but 1 does, it is non-removable. Or 1 may not. All right?